Hi everyone, those online with me. Thank you for joining me. I hope you can hear my voice. Huh? Okay, tonight I will discuss chapter 7, quantum physics. Okay, 7.1, this is about quantum theory of light. Okay, so in this first part, you are introduced to the concept of black body. Yeah, what is black body? Okay, black body is an idealized body, yeah, that able to absorb all electromagnetic radiation, okay, that falls on it. It can emit a thermal radiation depending on its temperature. Okay, so if able to absorb all range of electromagnetic radiation, I hope you still remember the spectrum of electromagnetic waves starting from gamma, okay, X-ray, okay, visible light, infrared, then we have microwave and radio wave. Okay, so we can see there is a visible light which is conceived of seven colors, right? Orange, yellow, green, blue, indigo, and violet. Okay, so if the black body can emit radiation depending on temperature, meaning if you can see the color, okay, the color will be in this spectrum, the visible light. If higher temperature, the color will be more to violet. If you compare the temperature, the blue one is hotter than the red one. So at low temperature, it will emit uh, red color. At high temperature, it's more to blue and to violet. It's something like that. Okay. Object emitting electromagnetic radiation, which is determined by its temperature. Okay. So if you can see the color means it is under visible light spectrum. Okay. Electromagnetic radiation that include visible light and radiation that cannot be seen by human eye, such as infrared radiation. So outside the range of visible light, all these we cannot see. Yeah, see. For the first part also, you are introduced to classical physics and also the quantum theory. Yeah, quantum theory. What is stated by the classical physics is that electron that vibrates at same frequency should have same energy content. Meaning, as temperature increase until unlimited, the intensity of light also become unlimited. That one is classical physics. But based on experimental result, okay, when reach certain value of frequency, which is high frequency, at range of for the ultraviolet, suddenly the intensity drop to here. This part, you can see the green color drop. So according to classical physics, it will continue to increase until unlimited, meaning when temperature increases, frequency become unlimited, intensity also unlimited. But according to experimental result, that does not happen. Okay, the intensity of light such as UV will drop to zero here, this side. Okay, so this one they call it UV catastrophe. That one is a challenge for the classical physics. Okay, that means the classical physics cannot explain this one, the result of the experiment. Okay, only the quantum theory that able to explain this part. Okay, we go to the classical theory. These are the scientists. Okay, Isaac Newton, particle nature of light. Okay, for the first part, for the classical theory, he failed to compare speed of light in glass and air. Okay, this one study about particle nature of light. And then we have Thomas Young, also unable to explain radiation spectrum that produced by black body. Okay, why suddenly the light intensity drop? Okay, at UV range. John Dalton, also unable to explain light spectrum produced by atoms. J.J. Thomson, also unable to explain line spectrum of light produced by atoms. So means they cannot explain the experimental result. So the classical theory looks like it's a failure. Okay, then come quantum theory. Okay, quantum theory. So we have this one, Max Planck, study about quantization of energy. Okay, means energy in each quantum directly proportional to wave frequency. Okay, so based on the Planck quantization theory of electromagnetic wave, explain black body radiation spectrum. So now they are able to explain by using quantum theory. Then Albert Einstein, also successful explaining characteristic of photoelectric effect. Later we discuss what is photoelectric effect that cannot be explained by classical theory. Okay. Then we have this one, Niels Bohr. Niels Bohr, okay, explain that electrons from higher energy level shell, when move to lower energy level, it emits photon, light energy in form of photons. Okay, and then Louis de Broglie, okay, a very popular theory wave particle duality. Okay, means this one also together with Einstein, they have this idea that wave particle duality of light and all subatomic particles, which involve very small mass of particle like proton, neutron, electron. Okay, so all these, the quantum theory, important person that able to explain the classical theory. Explain why classical theory is a failure. Okay. Okay, I go a bit fast for this part, 7.1. So quantization of energy. So based on the quantum theory, light energy travels in form of energy packets. Okay, photons that we call photons. Okay, photons is light energy packet, macam bungkusan. Okay, light travel not in continuous form. Okay, maybe in the wave theory, we discuss about light travel in continuous form like this. But according to quantum theory, light not travel continuous, but in packets. One packet, two packets, three packets. Okay, this one is the light. So light travel in packets. We call it photons. So we can count how many photons emitted. That one is quantum theory. Okay, quantization of energy, we just look at this one. This is the visible spectrum. So this one is continuous spectrum because we cannot see clearly where is the range for the red color. Okay, no limit, light continuous. So we call it continuous spectrum. Okay, produced by dispersion of white light by prism, no separation gap between each color. Okay, we cannot determine where is the exact position, the red color end. Where is the starting point for the yellow color? That's why we call it continuous, continuous. Okay. This is line spectrum. So you can see in form of line, of course. This one produced by excited electron, meaning an electron with higher energy. Each element produces spectrum with series of its distinctive lines, unique lambda and f. If line spectrum, you can determine its frequency accurately. Means if this line is here, the value is 500, for example. Okay, it's something like that. So the light spectrum, it has its own distinctive lines. Okay, itu maksudnya line spectrum. Not continuous, discrete. Okay. Ini yang tadi saya dah sebut. Quantization of energy, discrete energy packets, not continuous energy. Okay, formula. Photons is light energy transferred in energy quanta. Okay, singular quanta, plural quantum. The energy packets, we call it. So the energy of one packet, we call it energy of photons. E equals to hf. Okay, where f equals to c divided by lambda. Speed of light divided by wavelength. Wavelength. That's from here we get energy of photon equals to hc divided lambda. What is this h? This one is Planck constant, 6.63 times 10 to the power negative 34 joule second. Okay, this one determined by experiment. Power. Power equals to number of photons per second. And number of photons per second, we call it n. How many photons emitted per second? That one is n. So it becomes power equals to number of photons per second multiply hf. Okay, so we have the formula power equals to nhc divided lambda. F ini substitute with c divided lambda. This one coming from the formula V equals to F lambda. Because of we discussed about electromagnetic radiation, all electromagnetic wave or radiation travel at speed of light c. C equals to 3 times 10 power 8. Okay, that's why we have C equals F lambda. So F equals to C divided by lambda. Okay, dapat formula ni. So sini dah ada dua formula. Okay, energy of photon, power. Okay. Okay, ini sample of a calculation. This one I have discussed in the class. For those not in the class, you can just try to answer the question again. Cuba jawab soalan ini. Okay, now I go straight away to wave-particle duality. Okay, the quantum theory. Okay, produced by very important scientists in quantum theory, Louis de Broglie and Einstein. Okay, why there is the word duality? Duality tu ada dua lah, double. Wave particle duality means it shows both properties of wave and particle at the same time. Okay, if wave properties mean it can undergo all phenomena of wave like diffraction, interference. For particle properties, it has kinetic energy and momentum. If you still remember, formula for kinetic energy, E equals to half mv squared. Okay, and then momentum, P equals to mv. Okay, so it has mass, means it function like or behave like a particle. Okay, can light show properties of wave and particle at the same time? Okay, so Louis de Broglie hypothesis, all particles can exhibit wave characteristic. Okay, jadi dia guna electron for the experiment. Very small mass electron. Okay, lambda equals to h divided by momentum. Okay, so from here we get momentum equals to mv. Thus we have lambda equals to h divided by mv. Okay, this is, we call it wavelength de Broglie. Okay, ataupun de Broglie wavelength, we call it. Okay, defined as lambda equals to h divided by p. Okay, h is Planck constant, p is momentum. So you just substitute p with mv, so you have lambda equals to h divided by mv. Okay. Okay, now if this one has a momentum, so means it shows particle properties, So at the same time, of course, it has kinetic energy. So kinetic energy K equals to half mv squared. Okay, you just substitute here mv equals to what? Okay, from here mv. This is the mathematical operation. You just substitute here. Okay, from here is mv equals to mv squared 2k. Okay, now I want to have the mv side. So I have this one multiplied by m both sides. So I have m squared v squared equals to mk. Okay, from here I have mv squared equals 2mk. 2mk. Then mv equals square root of 2mk. Okay, so at here mv substitute with square root of 2mk. So we get this formula. Okay, de Broglie wavelength equals to Planck constant divided by square root of 2mk. K is kinetic energy. Okay, experiment done. The first one, diffraction pattern of red laser light through pinhole. Light exhibiting wave properties. Okay, what they diffracted. Diffraction pattern of electron through thin layer of graphite. Electron exhibiting wave properties. Electron is particle can behave as wave from here because it also experience diffraction. You can see diffraction pattern here. Okay, application for this one, we can use it in the production of electron microscope. Okay, de Broglie wavelength of electron is shorter than wavelength of visible light. Electron will be less diffracted than light. Electron microscope has higher magnification and resolution than optical microscope. Jadi kalau guna electron microscope, we can observe until 1,000 times bigger, especially for the cell like this. We can see it clearly by using this microscope electron. Itu adalah the invention which is very large, okay, produced by Louis de Broglie and also Einstein. Okay, let's look at some exercise on this. Because there are formula, of course, there will be calculation problem for you all to answer. Ada soalan untuk jawab. Okay, Planck constant, mass of electron, 1 eV, 1 electron volt, speed of light in vacuum. A laser light beam has wavelength of 600 nanometer. Calculate momentum of photon in the laser beam. Okay, what is formula of momentum? Okay, de Broglie wavelength equals to h divided by p. Okay, Planck constant divided by momentum. So we have momentum equals to Planck constant divided by lambda. Okay, so this one you can just substitute h 6.63 10 to the power negative 34 divide by lambda. Lambda given is in nanometer. So nanometer you need to convert to meter. Nano is 10 to the power negative 9 meter. Okay, so you calculate for this one, you will get lambda equals to 6.1. 6.1. Yeah. 1.1 times 10 to the power negative 27. Okay, unit apa? Unit momentum. Same as the topic momentum. Kg meter second negative 1. So this is the momentum of photon in the laser beam. Okay, given that frequency of light wave, calculate momentum. Okay, you want to calculate momentum, P equals to H divided by lambda. From the formula of C equals F lambda. So lambda equals to C over F. Okay, calculate momentum. P equals to H divided by lambda. So substitute lambda with C divided by F. We have H F divided by C. Okay. So the formula. Substitute the value of H, the value of frequency, and the speed of light. Okay, so we get like this. Okay, 1.65 times 10 to the power negative 27 kg meter second negative 1. Okay, you just substitute. Frequency divide by 3 times 10 power 8. Okay. Answer just now is 1.65 27 kg meter second negative 1. Okay. So this is momentum of the light given. So means you must know what formula that you can use to get the answer. So you must get familiar with the formula. You can check the list of formula given. Okay, part C, given the de Broglie wavelength 1.23 nanometer, calculate momentum, velocity, kinetic energy. Okay, look at the first one, momentum, P equals to H divided by lambda. Okay, and check the answer. H divided by lambda. You substitute as usual. Before divide by, this one is nano, you need to change the meter. 1.23 nano is 10 to the power negative 9. Okay, so you will get the answer 1.65. 5.38. Okay, you must try. Check whether you get the same answer as mine or not. Okay, part 2, velocity. Okay, velocity is something to do with the kinetic energy. Yeah? What formula that we should use? Okay, so means K equals to half mv squared. Guna formula tu. Daripada formula momentum also, P equals to mv. You boleh calculate juga. Momentum equals to mv. Okay, momentum calculated here. 5.38 10 power negative 25. Okay, mass of electron given 9.11 times 10 to the power 31. This is mass of electron and this is the speed. Okay, so you find the value of speed. So we get the value here equals to 5.9 times 10 power 5 meter second negative 9. Okay, so using the formula of momentum, P equals mv. Okay, you calculate, you get the value of speed. And then to calculate kinetic energy, formula of kinetic energy is half mv squared. This one we just calculate for one electron. You can see n electron. One electron, so mass of one electron, speed of the electron. Okay, that we discussed. Okay, you just substitute here mass and also speed. Okay, mass is 9.11 times 10 to the power negative 51. Speed 5.9 times 10 power 5. Okay, ada square kat sini. Okay. Gantikan. Ini 5.9 10 power 5. Okay, gantikan, then you calculate, you will get the answer. Okay. Here, 1.59 10 to the power negative 19 joule. Okay, so you can see this is the answer. This is mass of one electron. This is speed of the electron. Okay, so you get kinetic energy of electron. Okay, part D, how much kinetic energy does one electron have when d Broglie wavelength is 400 nanometer? Okay. Okay. We can use this formula again. d Broglie wavelength equals to h divided by square root 2mk. Okay. Square root 2mk equals to h divided by lambda. Okay. H divided by lambda. Okay. So this one will cause you all to square root both sides. Okay. So you square both sides. Square both sides. So this one will become 2mk. This one become h squared over lambda squared. Okay. So from here, k equals to h squared divided by lambda squared times 2m. Okay, just substitute h. H is Planck constant, so you will get kinetic energy. Okay, this one by using this formula, we can try, or k equals to half mv squared. Half times 9.11 10 to the power negative 31. Speed just now we get from the first part, use ini speed 5.9 10 power 5. Sorry, itu soalan lain sekejap. Check sekali. Sorry itu D tadi saya salah tengok. Okay So how much kinetic energy? 1 electron. So D Broglie wavelength 400 nanometer. Okay. Okay, here we get. So there's no other formula that can use unless we have the speed, then can calculate for using this formula, half mv squared. Okay, but this case we don't have the speed, that's why we need to use this formula. Okay, so you must get familiar with this one. This is the formula for de Broglie wavelength, wave particle duality. Okay, untuk E, part E, given a laser pulse power 60 megawatt. Ini adalah power, wavelength lambda. What is momentum of one photon from the laser pulse? Okay. Okay, formula. Daripada formula momentum, de Broglie wavelength is Planck constant divided by momentum. This is de Broglie wavelength. So P equals to H divided by lambda. 6, 3, 10 power, negative 34, divide by 800, 10 power, negative 9. Okay, so we get the answer for this one. E1, E1, 8.28. Okay, so you can try to calculate yourself, whether you get or not this one. How much energy does one photon carry? Okay, I just showed straight away the answer. Okay, part 2, energy of photon, E equals to HF. F equals to C divided by lambda. So we have E equals HC divided lambda. Okay, so H ialah 6.63 times 10 power negative 34. C equals to 3 times 10 power 8. Divide by 800 nanometer. Nano you convert to meter. We get 2.48 10 power negative 19. Ini part 2. Okay, energy equals to HF equals to HC divided lambda. 6.63 10 power negative 34. C 3 times 10 power 8 divided by lambda. 800 10 power negative 9. Okay, so we get energy of one electron, 8.28, 2.48, 19 joule. Okay, unit for energy is joule. Number of photons per second. This one come from the formula of power, P equals to NHF or NHC divided by lambda. Power given 60 milliwatt. NHC divided by lambda. We want to find what is N. Okay, we want to find what is N. N is number of photons per second. Okay, so power ialah 60 milli. Milli is 10 to the power negative 3. N, number of photon per second. Hc divided by lambda is energy of a photon just now. Energy of a photon calculated already. Okay, from part 2, 2.48, 10 power negative 19. And then you can find N equals to power divided by energy of an electron. Okay, divide by energy. So you get 2.4 times 10 power 17 per second. Okay. (60) 10 power negative 3 divide by energy of one photon. Jadi 2.48 10 power negative 90. Okay. So we get the answer 2.4. 17 second negative 1. So ini number of photon per second. Number of photon per second. What is total momentum transferred by the laser pulse per second? What is total momentum? So formula is NP. If you calculate P equals to MV atau P equals to H divided by lambda, that one just for one photon. Okay, you want to calculate for N number of photon, meaning NP, NP. So you have N multiply P tadi, momentum, okay, of photon. Okay, so you will get 8.28 times 10 power negative 28 multiply N. So you get 2 times 10 power negative 10 kg meter second negative 1. Okay, so formula ni memang kalau you tak biasa rasa susah sikit. Tapi kalau you biasa buat latihan, so that one I think okay lah, boleh jawab. Okay, next question. A student bombarded sand with mass 2 times 10 power negative 9 kilogram through small slit, speed 0.5 meter per second. Size of slit given as 0.5 millimeter. Assuming sand is small enough to pass through the slit, estimate de Broglie wavelength of the sand. Okay, so de Broglie wavelength kita tahu H divided by P, and also equals to H divided by square root of 2 mk. Okay, P equals to mv, momentum. Okay, so H divided by mv, you will get wavelength. We want to find lambda. Okay, so just use the formula. Lambda equals to H divided by mv. Okay, so 6.63 10 power negative 34 divided by mass 2 times 10 power negative 9 d 0.5. Okay, so we get de Broglie wavelength, which is equals to 6.63 10 power negative 25 meter. Okay, so this is the estimation for the de Broglie wavelength. Will diffraction pattern be observed when the sand passes through the slit? Explain your answer. Okay, you can see very, very short wavelength. Okay, if the wavelength is too short as compared to the size of gap, diffraction cannot occur. Okay, so when diffraction cannot occur, it cannot show the wave properties. Okay, wave properties. That's why for the sand, which is a mass very large like this, it cannot show the properties of wave. So wave particle duality is not applicable for sand. Wave particle duality just applicable to the very, very small mass like mass of electron. As you know, mass of electron berapa tadi? Very, very small. 10 power negative 31. Okay, so means this de Broglie wavelength just can be applied to a very, very small mass of particle like electron, proton. Okay, for this case of sand, it cannot show properties of wave. So cannot show wave duality properties. Okay. Itu ialah 7.1, the concept of wave particle duality. Also formula that we have discussed. Okay, let's try to refresh what we have discussed the first part. First part we discussed about black body which can absorb Okay, all range of electromagnetic radiation. Okay, the radiation emitted depends on its temperature. Okay, the object may be appear red at lower temperature, but can be appeared blue at very very high temperature, something like that, because it emits radiation. Different color depends on the temperature. And then we discuss about energy, a concept of energy photons or light energy in the form of energy packets, not continuous. And then we discuss formula. Formula ada berapa? Kita dah discuss. Kita ada energy of photon, E equals to HF or HC divided by lambda. And then we have the formula of momentum, P equals to mv. Okay. Okay, lagi satu, ini ya, berapa? Wavelength, D broadly wavelength, H divided by P ataupun H divided by mv ataupun H divided by square root to mk. Okay. Number 3, we also discuss about power, rate of photon per second, NHF ataupun NHC divided by lambda. Okay, so ini adalah formula-formula yang you kena biasa guna. Okay, yang basic ialah kinetic energy half mv squared. Okay, momentum P equals mv. Ini yang you dah belajar in form 4. Okay, dah belajar dah. And remember, for the wave particle duality, it just can be applied for very, very small mass, like electron, protons, not applicable to large mass. Even though, okay, sand also cannot show, it's quite large already, the mass. So very small mass. If you look at the formula from here, because the Planck constant itself also already very, very small, 6.63 times 10 power negative 54. If divide mass which is large, the value of wavelength become very, very small. Okay, if the wavelength very, very small as compared to the size of gas, diffraction cannot occur. Okay, diffraction cannot occur. It's not obvious, cannot be seen clearly, the effect of diffraction. Okay, that's why wave particle duality for a very small mass only. Okay, you can read more on this. Boleh baca lagi tentang ini berkaitan dengan wave particle duality and the formula that can be used to calculate in the calculation. Okay, 7.2 we have photoelectric effect. Okay, just now we have discussed that energy or light energy in the form of packets. Okay, light travel in the form of quanta or energy packets that we call it photons. Okay, so light can behave as the particle. It can behave like particle means it also can show properties something like particle. It has momentum. Okay, it has kinetic energy. It can produce collision. Okay, something like that. Okay, photoelectric effect, emission of electron from metal when metal surface illuminated by beam of light at certain frequency. Okay, light coming, shine on the surface of metal. Below the surface, there are a lot of electrons. Electrons just stay below here. Okay, at certain frequency of light, okay, electron suddenly can emit from the surface of metal. Okay, at certain frequency only, not all frequency. Okay, at that certain frequency, we call it threshold frequency. Okay, means it already gain the same frequency as the metal. Okay, means light frequency equals to threshold frequency of metal. So when this happens, electron can be emitted, or we call it photoelectric effect. Okay, electron emitted from the surface from when the metal surface illuminated ataupun is shone by beam of light at certain frequency. Okay. Contoh sini kita ada photocell circuit. Cathode ni is a piece of metal. Means dia ada banyak electron below the surface. This is anode. The metal is connected to cathode. And there is a power supply. And this is milliammeter. When the cathode is shone by light at certain frequency, what happens? Light beam illuminates light sensitive metal surface, cathode. Okay, electron will be emitted from metal surface. Okay, let's say the frequency of light equals to the threshold frequency of electron. Now electron can release itself and come out from the surface of metal, or we call it photoelectric effect occur. Electron that emitted, we call it photoelectrons. Photoelectron is negatively charged. It will be attracted to anode. Okay, so once it attracted to anode, the circuit become completed. When circuit completed, milliammeter will show current. Okay, so once the milliammeter show current, means photoelectric effect already occur. Elektron dah keluar dah. Okay, sudah berlaku photoelectric effect. Characteristic of photoelectric effect: the higher the frequency of photon of light, the higher the kinetic energy of photoelectrons emitted from the metal surface. Okay. Threshold frequency FO, minimum frequency of light needed for metal to emit electron. Okay, so metal, okay, if electron emitted from the surface of metal, means it's already gain ataupun achieve minimum frequency required. Means the light coming same frequency as the threshold frequency of the metal. So when this happen, electrons will be emitted. Okay. Kinetic energy of photoelectron does not depend on intensity of light. Photoelectrons emitted instantaneously when metal surface is illuminated by light. What does that mean? Okay. Let's look at the table below. Let's say low intensity of light. Okay. Frequency of light lower than threshold frequency of metal. If frequency of light is lower than the threshold frequency, no photoelectric effect occur. Dia at least equals to threshold frequency, then only the electron emitted. Now less, so no photoelectric effect. Electron cannot emitted. Okay? If frequency of light higher than threshold frequency, then only electron can be emitted from the surface of metal, or we call it photoelectric effect occur. Okay, let's look at high intensity of light. Same frequency but high intensity. Lebih cahaya dia lebih bright lah, high intensity. Okay, but frequency of light still lower than threshold frequency. Even though at high intensity, still no photoelectric effect occur. Okay, masih tak berlaku. Sebab dia tak penuhi syarat. Okay, syarat ialah frequency of light at least equals to threshold frequency. Cannot be less than. Okay. What happens if the frequency of light is more than threshold frequency, at the same time high intensity? Yes, photoelectric effect occur. More photoelectrons emitted. Okay, so if you look at the reading of the milliammeter, the reading will increase. Okay, or the current increase. Means the current produced, okay, current produced depends on intensity of light. But photoelectric effect does not depend on intensity of light, but depends on the frequency of light. If the frequency of light reach the minimum value of frequency, which is threshold frequency, then electron will be emitted. Okay, so photoelectric effect occur only when frequency of light okay, is larger or equals to threshold frequency. Okay. Okay, we have this experiment to determine Planck constant. This is LED potentiometer, battery milliammeter. Okay. When you turn on the switch, at certain value of voltage, okay, turn on using the potentiometer to increase or decrease the voltage. Let's say small voltage, less than VA here. The current is 0 here, this part. Okay. So what happens for this one actually, okay, it does not reach the activation voltage. Okay, for this part. Okay, once reach the certain value of voltage, suddenly current increase. Okay, suddenly current increase, the green color. Okay, you can try with a different wavelength of light to show the activation voltage. Okay, so we have this one, activation voltage against 1 over lambda. So we get this line of graph. Gradient equals to Hc divided by charge of 1 electron. Okay. Let's look at the exercise here. Low intensity, threshold frequency 10 Hz. Frequency of light less than threshold frequency. Can photoelectric effect occur? No. Okay. Kinetic energy of photoelectron, we cannot determine. Tak ada. No photoelectric effect. Okay, ataupun boleh cakap very ataupun zero lah sebab belum lagi. Number of photoelectron release also no, tak ada. Okay, because photoelectric effect not occur. How come electron cannot come out? So electron cannot come out from the surface of metal. Okay, look at the high intensity. Okay, high intensity, same frequency. Still for this one, F less than threshold frequency. So ini tak ada. Okay, apa pun tak ada juga sama. Okay, tak ada semua. Okay, semua tak ada. Okay, let's say for the low intensity, but now frequency of light is more than threshold frequency. Okay, if more means, okay, photoelectric effect occur. Kinetic energy low because low intensity. Okay, total photoelectrons emitted also low. Okay, part D, low but frequency is higher. Okay, frequency is higher daripada threshold frequency. So like ni you nampak frekuensi sangat tinggi lah. Ini 11, ini sudah jadi 55. Okay. Okay. Kinetic energy increases. Okay. Number of photoelectrons decreases. Okay. For this one, high intensity, photoelectric effect occur because F is larger than FO. But for this one, kinetic energy low. Okay. And then the number of photoelectrons also increase because intensity increase, number of photoelectrons increase. And then this one, high intensity, okay, photoelectric effect occur, of course, because F is more than FO. Okay, high frequency, High frequency means high kinetic energy, high number of photoelectrons. So means if we have measure the current, means the current also higher. Okay. Okay, calculation. Kena buat lagi sekali. Okay, you all can try this one. Okay, 7.3 Einstein photoelectric theory. Photon energy in form of packets when shine onto the metal surface, electron will gain energy if frequency of light, okay, larger or equal to threshold frequency of metal, electron will be emitted or photoelectric effect occur. The value of energy that required for photoelectron to be emitted, we call it work function, W. Okay, work function, W. Minimum energy required for photoelectron to be emitted from the surface of metal. So energy of photon E we have discussed equals to HF ataupun Hc divided by lambda. Okay, work function, minimum energy required or the minimum frequency required FO. So we have work function equals to HFO. Okay, so HF equals W plus K maximum half mv square max. If the frequency of light just equals to frequency of the threshold frequency of metal, photon energy just equals to work function, which is equals to HFO. In the case of frequency equals to threshold frequency. So you will get energy of photons equals to work function equals to HFO. If the frequency of light is more than FO, if more means there is extra energy that convert to kinetic energy maximum. That's why the energy of photon is equals to work function plus K max. Okay, work function equals to K max for the case of frequency larger than threshold frequency. If frequency of light equals to threshold frequency of metal, energy of photon just equals to work function, HFO. Okay? Let's look at this one. Let's say photon has 10 joule of energy E. After it hits the metal, 3 joule is used to release electron. Extra 7 joule is kinetic energy of the escape photoelectron, Kmax. So this one based on the principle of conservation of energy. Total energy before 10 joule, total energy after is 3 plus 7. Okay, look at this graph again. Kmax against frequency. Okay, let's say we have different material here, metal A, B, C. Okay, metal berbeza A, B, and C. Okay, when we plot a graph, you can see the ABC graph all will intersect at f-axis at certain value f. So this certain value, we call it threshold frequency. The minimum frequency required for photoelectric effect to occur. Okay, so this is the minimum frequency required. Okay, different metal have different FO and W. Gradient equals to Planck constant. X-intercept threshold frequency, Y-intercept work function. dari sini pun boleh juga. FO threshold frequency, lambda O threshold wavelength. Okay, because from here, from the formula, threshold frequency and threshold wavelength inversely proportional to each other. C over FO equals to lambda O. Okay, means if FO is the minimum frequency required, means this lambda is the maximum value of wavelength. That's why the word here, maximum wavelength of light needed. Okay, so this one is threshold wavelength. Threshold wavelength. How we get the gradient equals to Planck constant? Okay, we refer again to the formula just now. E equals to work function plus K maximum. Okay, ini adalah yang first tadi. Work function equals to HFO. Okay, what is K maximum? Okay, K maximum. Kita nak plot graph ialah K max against F. K max against F. So make it K max as a title. Okay, so we have K max equals to E is HF, energy of photon. Energy of photon. Ini ya, HF, E. E equals to HF. Okay, so HF minus W. W equals to HFO, threshold ataupun work function. Okay, you can factorize this one. F minus FO, K max. Okay, so we get H equals to K max divided by F minus FO. If we look at the graph here, let's say we look at metal A, metal A. Find the gradient of this one. Means K max, okay, K max equals to, what is this length? What is this length? Let's say ini adalah F, means F minus FO. Okay, F minus FO. So the ratio of K max divided by F minus FO actually equals to Planck constant. That's why Planck constant equals to gradient of the graph. So Planck constant is a gradient of this graph. Okay, example graph on the right shows change in kinetic energy of photoelectron released from metal for different light frequencies. Okay, determine threshold frequency. FO. Kalau you gunakan formula ni lagi sekali, E equals to HF minus HFO. Okay. Kalau you compare dengan formula, Y equals to MX plus C, gradient, ini gradient, ialah Planck constant. C atau intersect is HFO. HFO ni ialah work function. Work function. So we can get gradient equals to Planck constant intersect at C. Maksudnya if you extend the graph below, bahagian negative, then you sambung garis ni, it will intersect here. So this is C. So the value of C here is W equals HFO, work function. Okay, that's why the it mentioned just now, gradient equals to Planck constant, Y-intercept ataupun K max intersect equals to work function HFO. Okay, jadi dari graf kita dapat itulah daripada graf tadi. Okay. Okay, calculate A. Determine threshold frequency. Threshold frequency X intercept. So just read from the graph what is the value. So 6 times 10 power 14. Ini 6, ini ada times 10 power 14. So you get the threshold frequency. Calculate work function. Work function equals to HFO. FO dah ada, terus ganti saja. Okay, 3.98 times 10 power negative 19 joule. Okay, look at exercise. Planck constant, mass of electron, 1 eV, speed of light in vacuum. Okay, violet light frequency, F. Okay, shown on calcium metal surface, what is maximum kinetic energy of photoelectrons? Work function of calcium. Okay, HFO. Dia dah bagikan 10 power negative 19. Okay, so we want to find the K max from this one. Okay, K maximum equals to HF minus H ataupun energy of photon minus work function, because already given the work function. So you can substitute 6.63 10 power negative 34, frequency 7.5 10 power 14 minus work function. Okay, dah diberikan. Ya. 4.6 with 90. Okay. Okay, so you will get the K maximum. K maximum. Ya. You gantikan terus HF minus W. Okay, kita dapat jawapan dalam unit joule. Okay, bahagian B, red light wavelength 700 shown on calcium metal surface. Can photoelectric effect be observed? Show your working. Work function also given. Wavelength 700 10 power negative 9. Okay, so you want to know whether the photoelectric effect can occur or not. Given the work function of calcium, so we can calculate the threshold frequency dulu. Okay, calculate by using Hc divided by lambda. So you get 2.81, 2.84 times 10 power negative 19 joule. So energy here. Okay, compare to the work function. Is it enough or not, this one? Work function already calculated. Already given work function. Look at the question again. Work function 4.6 10 power negative 19. So you compare the value that you get with this value. The value of energy that coming from the light must be more than or at least equals to work function of calcium. Okay, so if you can calculate for that one, you will get the answer. Okay. So you get this value. If you compare to the work function tadi, 4.6 negative 19 joule. Means ini tak cukup. At least sama dengan ni, lebih tak apa. Okay, so not enough, so photoelectric effect cannot occur. Tak cukup energy. Work function saja pun sudah 4.6. Ini hanya 2.84, so not enough. Okay, at least must equal for photoelectric effect to occur. Okay. Okay, bahagian seterusnya C, a semiconductor material photocell activated by light, maximum wavelength 1500 nanometer. Calculate threshold frequency and work function. Okay, threshold frequency FO. Given maximum wavelength is threshold wavelength, lambda O. Okay, so part 1, you want to find the threshold frequency, so just use the formula C divided by lambda O. Daripada formula C equals to F lambda. So just substitute C, 3 times 10 power 8, divide by 1500, 10 power negative 9 meter. Okay, calculate for this one, you will get FO, FO, threshold frequency. Okay, 2 times 10 power 14. Okay, untuk bahagian C. Okay. Okay. Work function, you just substitute value of FO into this formula. W equals HFO. Okay, you get the value of FO from here. So get 1.33 times 10 power negative 19 joule. So ini adalah work function required for electron to be emitted from surface of metal. Maksudnya kalau energi dia tak sampai value ni, dia tak boleh keluar elektron tu. Itu maksudnya. So minimum mesti equals to threshold frequency. Okay, the frequency of light. Okay, bahagian D. Minimum energy required to escape, kita panggil sebagai work function. Formula HFO. From a metal surface is 2.5 eV. What is threshold wavelength of the metal? Okay, bahagian D ni kena faham soalan. Soalan bahagian D. Okay, this is the energy. Okay, E equals to Hc divided by lambda. So you can get lambda equals to 4.97 times 10 power negative 7 meter. Okay. Okay, so itu sahaja untuk topik quantum physics secara ringkas. If you want to have very detailed explanation, you can watch my video on this topic. I explain based on the textbook, start from 7.1 to 7.3. For this part, just discuss how to use the formula only. So this one is quite short. I understand it's very hard for you all just to understand by just explain this one. You must go and read the textbook at the same time. Kena baca buku teks and try to answer exercises in the textbook or reference book. Okay, so I think itu sahaja. Thank you. Bye.